All right, good afternoon, everybody. Thanks for joining me today. So in this session, we're going to be talking about security best practices for all different types of virtualization. We are going to focus specifically on VDI, service providers, hosting companies, but these best practices are going to be applicable for anybody using Hyper-V. So who here uses Hyper-V? Okay. Who here is VMware? Okay, well, good news is all of these best practices are still applicable, okay? We are going to be focusing on Hyper-V. We're going to be doing the demos using Azure Pack, Hyper-V technology, things like that, but all of these best practices are fully applicable. Now, I'm Symon Perriman. I'm currently Vice President of Five9 Software. We actually do security as well as management for Hyper-V, so that's where a lot of my expertise comes from. I spent 8 years with Microsoft prior to that. I was a technical evangelist. I did a lot of work on the Microsoft Virtual Academy, and I spent 4 years actually on the Hyper-V engineering team, building a lot of the technologies around high availability. So hopefully you get a lot of best practices here. I am going to ask you guys not to ask questions, hold off until the end, but I will stay around after the session. Happy to talk with you guys after that if you guys have any other questions. So let's get started. First, we're going to talk about security in general for virtualization admins. Now, my background, I was a virtualization guy. I've never been a security guy. And so that makes it tough for a lot of virtualization admins to just kind of get up and running and understand, what are the best practices? How do I get started? Especially if you're in a smaller company that doesn't have dedicated security people. Because in that case, you're the virtualization guy, yet you still need to make sure that the VMs are protected. That's a challenge, but we're going to kind of walk through an introduction, give you kind of the foundation of the different types of tools that you can use. We're then going to take a look at best practices around VDI, so enterprise client, best practices around service and hosting providers. But again, all of this is kind of just going to be everything Hyper-V. So let's start off with some foundational stuff. What are the different ways that Hyper-V or your virtualized environment can get attacked? Well, one of the most common ones is starving the compute resources. That's going to be your memory, the CPU cycles. We see a lot of viruses that will go and attack these systems that have dynamic memory, or in VMware terms, memory ballooning. And they'll basically consume all of the memory for that virtual machine. It will run task after task, and basically that VM uses all of that free memory CPU cycles. It starves other VMs running on that host. So we want to be able to limit memory attacks. We then have the network, and this is the most common area where you see attacks. Things are flooding the network. You probably heard of denial of service attacks, when you can't access a particular VM or service. This is when a particular virus is going to go flood the network so nothing can get in or out. And depending on what type of storage you're using, if you're using network-based storage, like iSCSI, SMB, something like that, NFS for VMware guys, that can also block access to the disk as well, because those networks also carry that disk information. You then have traditional storage attacks, which are basically starving the storage, using all of that bandwidth so nothing can get through. Now, if a VM can't access its disk, it means the VM's going to slow down, it's going to pause, it can't function. So we got to protect our storage being attacked. Now, on our website, most people actually access, or your customers are going to access your services through a website. Most common one you're going to see there is denial of service. But remember, that website's still running on a VM. So all of these best practices to avoid denial of service attacks on websites are going to be applicable here as well. And then the last class that we're starting to hear more and more about are advanced persistent threats. Now, this is becoming kind of a trendy word. Satya Nadella, Microsoft CEO, has even been talking about this in his keynotes. It's becoming that big of a problem. And basically, these advanced persistent attacks are attacks that specifically target certain types of infrastructure. It's not an all-purpose attack that just tries to flood the network. It's specifically targeting Hyper-V, or a DHCP server, or a DNS server. They're very, very well put together, very thoughtful, and very precise. And these are the toughest ones to actually be able to protect ourselves against. Because we can do these blocks where things are just trying to use all of our bandwidth or all of our memory. That's easy to prevent against. But these very specific attacks, they're hard to detect, hard to block. But we have best practices to cover all of these. Now, one realization that scares a lot of people here is that your data center is probably already infected with some viruses. Gartner did a report last year, and they said 90% of all data centers are already infected. Now, what is an infection? That doesn't mean that all of your servers are going to crash. Infections can be small things. An infection might be just trying to steal some information. A keylogger. So you may not even know that you have it. It doesn't just mean that your VMs are getting thrashed, but this is a reality. Most data centers already have viruses in. So what are the most common ways that they arrive? Well, first, probably the most common, especially for service providers and VDI, is the actual end user. Now, if you think about what these end users are, if you're doing VDI or you're a service provider, it's basically someone borrowing the hardware for a couple hours. They don't really care about security as much, especially if you're a service provider and you're renting this out to the public. If you're VDI and you're working with help desk, somebody logs in for 8 hours. They're not going to go spend time doing patches, installing security. A lot of help desks get attacked as well because they have customers sending them files. Those files can often contain viruses. So we've got to be really careful about the end users and tenants and try to be smart about locking them down. Storage devices is another huge way that we get attacked. And one of the most common threats that we're seeing now is bad guys will actually go to a data center or parking lot. They'll leave a USB drive just in the elevator, on the floor in the parking lot. Somebody says, hey, nice, a USB stick. Goes and plugs it into their computer, and they've infected the network. That's even happened in the United States government. Someone in the Department of Defense picked up a thumb drive, put it in their computer to see what was on it, and infected their internal systems. So you've got to be really careful from that physical security as well. And then the most common are network attacks, because most people are connected over the network. That's where your threats are going to arise. So we have a lot of best practices around protecting our networks as well. Now, another challenge is there's a lot of threats that haven't yet been identified. You may have downloaded a virus a month ago, but if there's no signature for it, you don't detect it. And a lot of these viruses are going to lay dormant until specific things happen. One of the most common ones you've probably heard of are time bombs. At the new year, at the end of a month, on a particular holiday, maybe during peak shopping season around Christmas time, the virus kicks in. And by that time, it's already infected dozens, maybe hundreds of servers and virtual machines. Those ones are really tough to track because you don't think there's a problem, and then all of a sudden, the entire infrastructure shuts down. Those are known as time bombs. Now, there's also another type that we're starting to see more and more, known as a logic bomb. And basically, there's a set of parameters where if they're met, only then will the virus get hit, such as when 100 servers have been infected, only then will it turn on and start doing bad things. And again, these are really tough to track because you don't even know you have it until it's too late. So you want to be really, try to think about these too. So what are some of the security tools that we're going to be talking about today? We're going to be talking about best practices with firewalls, antivirus, anti-malware, network traffic filtering, so actually scanning the traffic as it goes through the network, intrusion detection, and I'll stop here for a minute and kind of explain intrusion detection. So with a lot of these advanced persistent attacks, these very advanced threats, they do very unusual things where there'll actually be a specific traffic pattern. And if we can identify that specific traffic pattern, we know there's an infection, we can then go and lock it down. Now, the most common one is something like a denial of service attack on a particular service. If you kind of think about what a denial of service attack is, you have a single endpoint, like a VM or a website, and there's thousands or millions of connections going to it at the same time. Now, if you look at your normal data center usage, this is going to look unusual. You might only have 1,000 connections a day, and then all of a sudden you have 1 million hitting it. Well, that's actually something that we can define in code and say, hey, if we see this type of traffic pattern, this spike, there's probably an attack happening there. So intrusion detection is basically using heuristics, logic, to go and try to find these different types of threats. Now, everything that I'm talking about here, you can't forget just the standard security best practices. We're not going to be focusing on things like Active Directory, physical security, BitLocker, VPN. We're just going to focus specifically on Hyper-V here and the virtualization infrastructure. But reality is, security for virtualization is different. If you kind of think about how security was done 10 years ago before virtualization was big, you might have a dozen servers, maybe 50 servers. You would go and install a security agent on every single one of them, and that would do things such as run the scans, update the definitions, report back to you how healthy the system is. But the downside of installing agents on everything is that takes time, and it can actually open you up to other threats. Now in those old environments, if you only had 50 servers, doing this one time, not too bad. Maybe you add 2 or 3 more servers over the course of the year, install 3 more agents. Now think about virtualization, because it's dynamic. Things are different. VMs start up or shut down. You might not even know about them. You might have end users creating virtual machines that you as the administrator have no control over. This makes it really hard to actually go and install a security agent on every single one of those virtual machines, because they're unpredictable. Every time you got to go and log into these virtual machines to go and install a security agent, that slows down deployment. It's additional memory, additional CPU that's running inside that VM. And if you think about one of the key goals of virtualization, it's about consolidation, right? Run as many VMs as you can on a host. But now if you start to add these extra security agents inside each one of them, that's going to slow things down. So this is why virtualization for security is different. It's kind of a different model entirely, because you got to think about these dynamic environments. And we'll talk about how we solve this problem soon. Now, first best practice, make sure you use a solution that's actually designed for your virtualized infrastructure here. This was very surprising, but there was a while ago where Microsoft released a patch, and anybody that would run an antivirus scan on their Hyper-V virtual machines, it would cause the VM to be corrupted. It would actually kill these virtual machines. So what was Microsoft's best practice here? Their recommendation says, don't scan your disks, don't scan your virtual machines, leave your environment unprotected. That's pretty stupid. Now, the whole reason was a lot of these antivirus vendors, they actually just built an all-purpose security system. They tested on VMware, they tested on Hyper-V, but it's not really designed for any of those one specific infrastructures. So all of these antivirus vendors, including the big names, McAfee, Trend Micro, Symantec, a lot of them hit this problem where their customers were corrupting their virtual machines. Or, as Microsoft's best practice said, don't protect them. Really bad best practice. So you want to make sure that you do have a solution designed for your virtualized infrastructure. So let's go ahead and take a look at our best practices around VDI. Now, first thing, let's kind of think about how a virus will actually arrive inside a virtual machine. You're going to see it has to go through the network. Now, in some cases, yes, you have that physical thumb drive people plug in, but for the most part, your virus is going to arrive through the network. Now, if you think about that flow of the network packet that contains the virus, it's going to go through the Hyper-V host. It's going to go through the virtual switch on the host, which does all the routing and the logic. It then goes to the virtual network adapter, and then finally the virtual machine. So one of the best ways that we can do agentless protection here and follow this best practice is actually do security at the virtual switch level. This is at the host. If we can actually prevent the virus from arriving inside the VM by blocking it at the host, we can protect those VMs without having to install anything inside them. Now, the way Hyper-V implements this, Hyper-V, as well as VMware, they have extensible virtual switches. And what that basically means is third parties, security companies, can actually go and plug drivers into this virtual switch, actually down at the kernel level. So this means that users can't tamper with it. It's down in the root of the operating system. And so this means that as the traffic goes through that host, through that virtual switch, we can intercept the packet. We can look at it and say, yes, this is safe. It could go through. Or we could say, no, this contains a virus. Or this looks like some other type of threat. We're going to block it. So best practice here, try to use an agentless solution. Now, next best practice, make sure you follow all of the isolation policies that you can. Now, Hyper-V, as well as VMware, they have built-in quality of service, or throttling. And what that basically means is you could put a maximum amount of bandwidth and a guaranteed minimum amount of bandwidth on every virtual machine. This prevents one VM from consuming all the resources on that host and slowing down those other VMs. So you want to turn on quality of service for your memory, or limit it, your networks, your disk I/O. Now, what we really want to do here as well is just make sure that any VM isn't going to go and impact any other VM. Again, keep them isolated. Make sure that one tenant isn't going to bring down another tenant. Now, next best practice, do not trust your end users. If you could get away with actually not having to install a security agent inside the VM, that's going to go a long way to make sure that your end users are not going to do anything bad. Now, one of the most common attacks that happens for service providers is actually from hackers. Now, hackers today, they're more sophisticated than 10, 20 years ago, right? When hacking first started, it was like high school kids doing this for mischief. Nowadays, hacking is a multi-billion-dollar industry. It's run by organized crime. It's even run by nation states like North Korea. They admit that they have fully dedicated hackers that are trying to go and steal other people's information, steal other companies' patents, things like that. Hacking has become a billion-dollar industry today. And one of the most common ways that attacks get launched is these bad guys will go and rent a virtual machine from a service provider using a stolen credit card, go commit their attack. That way it's really tough for them to trace. They didn't initiate it. It got initiated from someone else's data center. And the way that these hackers do it, after they get access to that virtual machine, they simply uninstall the antivirus or uninstall the security within that VM. So think about this best practice, right? If we can avoid having any security component running inside the VM itself, have an agentless solution, there's nothing for them to uninstall. So even if they try to commit an attack, we're going to go and intercept that at the host, we're going to block it, and it can't get through. They could go trigger their attack, their denial of service attack, send in illegal information, whatever it is, we could still go and block those threats. Now, another best practice comes around compliance. If you're a service provider, you're a hoster, or maybe even just running a large private cloud, in many cases, the admin should not have access to the virtual machine. You don't want to have the admin see what the tenant's doing. So that's another challenge that you have if you have to go and install an agent. Through scripts, through policies, you are somehow giving the administrator access to that virtual machine. Maybe they cannot log in directly and actually see the files, but if they can run a script that goes and installs the agent, they could go and execute other attacks. So as a best practice, you want to make sure that the admin stays isolated, that the admin doesn't have to log inside the VM and install things. This way you get more security. You meet more compliance guidelines. When you meet more compliance guidelines, you can actually grow your customer base as a service provider as well. So good things all around there. Now, our next best practice, of course, is keeping security signatures updated. Now, the security signatures, these are basically our definitions that say when a virus exists. Now, what's actually happening behind the scenes here for these security signatures is it's basically every single virus has some mathematical calculation of a really long number. So one particular virus might be something like 2.85 times 10 to the 87. And basically what's happening here is as these antivirus vendors are building up these libraries, they're using a hashing algorithm. And what that is, it's basically taking information about the file, such as the size of the file, the origin, the destination, all these different pieces. They run it through their engine to calculate this single large number. And when you do a scan of antivirus, you're basically just trying to match these large numbers. So when I go and scan my disk, it goes to the first file, it does the calculation, gets this really large number, and then sees, do I have a match? If I do, I have a match in virus. So that's kind of how these antivirus definitions were behind the scenes. So it's really important to make sure that you are working with some of the best in the industry. In the most recent study, I saw Kaspersky Labs, Bitdefender. Those two are ranked tied, #1. But there's about 20 to 40 kind of mainstream ones for the enterprise here. If you can, use multiple antivirus engines. There are some viruses one company sees, the other company doesn't know about yet. They're still trying to figure out their definitions. So if you are able to use multiple engines, that gives you better protection. Now, many of you probably already have a security engine. And keep in mind, Microsoft also has one that's built in as well, Windows Defender. So that's at least a way that you can get two going at once. Make sure you run both of these. There'll be some things that Microsoft detects first just because they understand their product better. There's going to be some that the industry detects first because that's their expertise. That's their specialty. Same thing with intrusion detection. Make sure you're using some of the industry leaders. And with intrusion detection, there's one that comes out way above the others, Cisco Snort. That was actually originally an open source product. Cisco bought them a couple of years ago. I highly recommend that for intrusion detection. And they actually give away a free version of it as well. The downside of the free version, you can only update your signatures once a month. So it's It's good if you don't have the budget and you still want an intrusion detection solution. If you get the Cisco Snort for Business Edition, you can update your definitions, I think, as frequently as every hour. But make sure you keep them up to date. And another best practice, try to have a centralized database. Now, what I mean by that is, think about if you have hundreds of virtual machines and each of them has to have the security agent locally and each of them has to have the definitions locally. If you're doing it in that model, the old model, it's really tough to ensure that every single one of those VMs has all of the definitions. You know, in many cases, people will have virtual machines that are offline for a while. They're not used. In some cases, people have a library of virtual machines where you just have it offline and you go and deploy a copy of it maybe every month. In those cases, those VMs aren't going to be current. Their security is going to be outdated. So if you are going with an agent-based solution, really important to make sure that that's updated. If you can work with an agentless solution, an advantage there is that you can centrally update all of your security policies. So if I can just update the security at the host level, that's one location, instead of having to go to the 20 virtual machines that are running on that host. So if you can centrally manage security at the host level, you're going to make sure you have better consistency, and as soon as a new VM gets deployed on that host, you don't have to worry about downloading definitions, because the host is already offering that protection. The host already has the definitions. So as it scans those network packets going through the network, that VM is already protected. Now, another good best practice here is use a virtual firewall and use one that's going to be global, that's going to apply to all different types of guest operating systems. Now, what I mean by a virtual firewall is a piece of software, not a physical appliance. The problem with physical appliances, they miss traffic that goes across private networks, that stays within a single host. And we'll talk more about that, I think, on the next slide. But by using a virtual firewall, we can scale it up. We can copy rules, and we can make sure that they're consistent. Now, for many hosting and service providers, they may have multiple guest operating systems, a combination of Windows Server, Windows Client, Linux, Unix. And if you're having to manage the firewall within each of those VMs individually, you have to use multiple firewall solutions. If you can manage your firewall centrally at the host level, you just need one. Because what we're able to do, again, we are intercepting those network packets at the host before they even arrive at the VM, putting them through a firewall, saying what's your source, what's your destination, what's your protocol. If you're safe, then you're allowed to go through, and this network packet's allowed to actually arrive at the virtual machine itself. So again, try to get a virtual firewall at the host. You get that consistency, global policies, and it makes administration a lot easier. So a best practice around virtual networks. Don't use a network appliance. So what I mean by a network appliance is a physical device that sits on the network. And this is how security used to work. If you use a legacy environment, great, use it. If you're highly virtualized, it's not a good idea. And the reason is it's going to miss traffic that never leaves the host. So in this example, I have an appliance here. And if I have traffic that goes from my first host to the second host, I'll go and scan it and I can say there's a virus here. But remember, when you have virtual networks, they can all live within a single host. You can have traffic that just goes from the host to the VM. That appliance misses it. You can have traffic that goes from one VM to another VM. That appliance misses it. And this is really bad because if one of your VMs gets infected for whatever reason, it can go through those private networks and infect every other VM on the host before you even detect it. So be cautious if you're using traditional network appliances because you are missing all of that private traffic. Now, there are some ways to work around it. You can route the traffic out by creating a tunnel, by creating a private VLAN, things like that. But if I have to go route the traffic from my host out to the external appliance and then back into that same host, that's going to take a performance hit. That's going to use more network traffic, so it's inefficient. And one way that we see viruses spread a lot is, one VM gets infected, it goes through that private network, but also through file shares and through storage. Because if you kind of think about a SAN or a file share, you still have multiple VMs that are accessing those same files. That's actually a pathway from one VM to another VM. The VM that's infected could go and place the virus on the file share. The VM that's not infected, when it goes and reads the file share, may pick it up. So you want to think about all of these different virtual networks, how to protect them, prevent these viruses from spreading. And keep in mind, those appliances probably have blind spots in your network. Now, another good best practice is using a technology known as active protection. Active protection does require an agent. This is an exception here. But what active protection does is it's going to alert you as soon as a virus arrives at the VM. So what's essentially happening here is as the network packet goes from that virtual switch to the VM, the way the technology works is it actually mirrors that network packet. It basically creates a clone of it and goes and runs a test against it. And so as this network packet is going through, this clone network packet is going through the security system, we're doing live matching of antivirus signatures. So if you have active detection, as soon as you notice that your packet has an infection, you can alert the end user. Now, this is really good for VDI environments, because if you think about VDI clients, right, they might be downloaded files. They probably don't care as much about security. So if you can have a mechanism that says as soon as that network packet contains a virus and it's going to your virtual machine, we're going to alert you, don't touch it, don't execute the file, don't open it. That's the way that you can tell the end user in a nice way that, hey, you're doing something bad, but we're going to protect you from being infected. So if you can, try to find a solution that does have active protection as well. Now, one of the biggest challenges with security are known as scanning storms. Now, a little earlier, I talked about how antivirus scans are done, right? We're basically doing a mathematical calculation on the file and matching the numbers to see if we have a match. Now, if you think about a virtualized environment, right, you've got lots of VMs on a host, it's very dense. You're using most of your resources already. And then you go and run an antivirus scan. Now, if you do this simultaneously, we've seen performance impacts of about 30%, meaning that all of the VMs slow down because they're all doing these calculations. There's not enough CPU cycles. So think about that. If you scan the entire host, every VM at once, every single file on every single disk on every single VM is having a mathematical calculation performed against it. That's a lot of CPU cycles. And these aren't small calculations, right? These are very, very large numbers that they're trying to figure out. And so just the fact that all of these calculations are happening at once, that's taking up a lot of CPU cycles towards the calculations. That means processing's not happening for your main application or main service. So best practices around this. First of all, stagger your scans if you can. Don't scan every VM simultaneously. Do one at a time. Another way that you can get around this is actually using a technology known as change block tracking. Now, what change block tracking does is when we have our virtual disk here, we're actually just going to detect the files which have changed since the last scan. So instead of having to scan my 1 terabyte disk each and every time, all I'm going to do is track which blocks on the disk have changed, and I'm going to scan those. So maybe I don't scan a terabyte each time, maybe I'm only scanning 1 megabyte, maybe 10 megabytes. This is a way that you can have these scans go much, much faster because you're not having to rescan the entire system every time. Now, as a best practice, you still want to be doing these full scans at some point, maybe once a week, but you don't have to do it daily. The reason why you still want to do a full disk scan is because there may be a virus that you downloaded a month ago that didn't have a definition yet. You now have a definition for it, so we can detect it. So best practice, try to stagger the scans, try to use change block tracking to minimize what has to be scanned, but always make sure you're still doing a full disk scan every now and then. Now, another key thing here as well is centralizing and automating your administration as much as possible. Now, if you're in a large cloud environment, you have more and more VMs being deployed, especially by end users. You want to be able to manage that from a single location. Again, try not to have to go and log into each and every VM to take a look at it. But automation's a key piece of this as well. If you can have automated security policies in place, you can scale. You can avoid human error by people forgetting to run a security scan. You're going to eliminate these time-consuming repetitive tasks of doing security. So make sure that you have an automation built into your security system, whether that's things such as scheduling or making sure that it supports PowerShell so that you can go and run scripts yourself. Create a PowerShell script that does a scan. Create a task scheduler task. Have that task go and trigger the scan, go and trigger the script. So there's lots of ways that you can do automation, but make sure that you have PowerShell support or Power CLI support for VMware people, so that your security system can scale, it can be automated as well. All right, I'm going to switch over to my first demo here and show you some centralized management from a service provider's perspective. Now, what we're going to be taking a look at here is known as Azure Pack. I want to distinguish this, that this is not Microsoft Azure. This is Microsoft Azure running on-premise. So why did Microsoft build this technology in the first place? Now, what actually happened when, I'm sure you guys have heard of Snowden, right? Snowden did lots of bad things for the whole cloud industry, because he made people realize that people's data wasn't safe. That was bad for the bad for the companies, but good for the customers. So after the whole Snowden incident, Microsoft only had its public cloud in about, I think, 17 or 18 data centers at the time. A majority of them were in the United States. I think here the closest one you guys have would be Amsterdam. There's one in Ireland as well. But the challenge is all about that data sovereignty. Who has access to my data? Where does it live? So after the Snowden incident, Microsoft and all of these big cloud companies lost a lot of customers. Because people in Norway, for example, realized, hey, my data isn't being kept in Norway. It's being kept on a server somewhere else that Microsoft has access to. Maybe even in the United States there's a copy of it. That means the US government can access my data. Now, a lot of rules around compliance for cloud have this strict requirement that the data cannot leave the country. If that's health, medical, insurance, legal, government, a lot of those kind of sensitive pieces of information have to stay within the national boundaries. So Microsoft said, look, we've got a problem here. We've got this awesome technology, Azure, but we don't have enough data centers. And we can't build $15 billion data centers in every single country in the world. That's not going to scale either. And they take about 3 years to build. So Microsoft said, okay, what if we productized Azure? What if we allow service and hosting providers to take that technology and run it on their hardware in their data center? So now people in Norway can still use Azure services, yet the data gets stored locally. That's the key advantage. It's not leaving the country. So that's this whole idea around Azure Pack. It's a localized version of Azure where you get to control where the data and where the information gets stored. But it's actually more than just the data where it gets stored. With Azure Pack, you get to have the full admin experience. And what I mean by that is you get to control all of the back-end policies. You get to control the size of the virtual machines, what type of storage they're running on, replication settings, and you can even add other types of plugins as well. And this is one of the other big differences from Azure. With Microsoft Azure, the public cloud, Microsoft runs the back end. When I go and use Microsoft Azure, I'm a tenant. I only see one experience, what the back-end people allow me to see. I can only deploy VMs that Microsoft lets me deploy. Microsoft has configured the size. Microsoft IT controls the policies. This is the other big advantage of Azure Pack in your data center. You get to be both the tenant and the administrator, so you get to control all the back-end policies. So let's go ahead and take a look at some of the back-end policies that we can use with Azure Pack here. So here I am, I'm using my tenant. I'm logged in as the administrator. Now, as the administrator, I see a bunch of different tools here. First thing that I'm going to do here is go and create a plan. And basically, a plan is a set of tools, a set of services that my end users can consume. So let's go ahead and say new plan. And this is usually what Microsoft IT does, but now I have access to this. And it's going to give me some information, so I'm going to call this my demo. And then it says what is going to be available for your end users. I can give them access to virtual machines, and I can give them access to control security. I then have some optional add-ons, there's none in this case, confirm the settings. And basically, I've now created this plan that people can have access to that gives them the ability to deploy virtual machines and the ability to go and secure those through self-service. So if I go take a look at this now, within here, I see that I've got my two different plans. I need to go do some additional configuration. We'll skip that for now, for the virtual machines. But through here, you get to go and centrally control and administer all the policies. So how many virtual firewalls they can use, how many VMs can have intrusion detection, how many VMs antivirus, and traffic scanning. So let's go ahead and take a look more about the centralized security settings, specifically focusing on security through Azure Pack here. So first thing that we see is we have a list of all of our different hosts. We'll have access to all of the virtual machines running on those hosts. Now, these VMs are not just my tenant virtual machines. These are also my infrastructure VMs as well. Remember, we don't just want to have these best practices around virtualization just for the end user. These best practices for virtualization are going to be good for everybody, for your infrastructure servers as well. So I can see I've got my SCVMM protected, my SQL server protected, and then I have a couple of tenant virtual machines here as well. Here I can go and deploy templates. Remember this best practice of creating these global templates? Well, this is a way that you can actually configure policies, such as the best practices for a SQL server, and then publish them for your end users, so that every time my end user deploys a SQL server, I get pre-configured all of the correct settings. So default firewall rules. Every time a new VM gets deployed, we're going to go and apply these different firewall rules. Again, it's all about this automation, instant and immediate protection. Now, through centralized management too, I can see what other users in the environment are doing, what they've changed, so that I can see if I have maybe an administrator that's done something bad or a tenant that's done something foolish and accidentally disabled their security. From here, we can see all the different tenants and their consumption. Now, remember, billing is an important part of security as well. Well, an important part of cloud services too. So it's really important to make sure that whatever service you have, you can hook it into your billing system so that you can charge your tenants based on their consumption. And then we have settings such as notifications. So every time somebody downloads a virus, we want to go send an alert. We want to make sure they know that it's happened so that they can go and do remediation. They can make sure that they don't open the virus. So that's a quick demo of centralized administration here. So let's talk a little more with a focus on service providers now. Best practice, automatic and immediate protection. We've touched on this a little bit. But remember, every time you deploy a new virtual machine, we don't want to go and log in and install security agents. It's going to slow down deployment. And did you know that when your VM first starts up, it's actually possible to inject viruses into the memory during the first boot as you're going and installing that security issue? So you want to try to have this automatic and immediate protection. Every time you deploy a VM, place it in a default security group. Make sure that it has all the firewall settings applied. And if you have the ability to do host-based protection, protecting at that host level, every VM that gets deployed on that host is automatically and immediately protected. Because remember, all of those security settings still live on the host. I could put a brand new VM up there, nothing has to run inside that VM, but I'm still going to be able to protect it because I already have my firewall policies configured. Scanning's on. All of these best practices already apply. And this is really important for these dynamic cloud environments where things are constantly changing. Best practice, use an enterprise security solution as well. You got to make sure that your security solution doesn't have flaws in it. You want to make sure that it can be centralized. So if you're using System Center, for example, to manage all your virtualized resources, consider a security solution that has a plugin for that. Similar for vCenter. Security must be remote. You got to make sure that you can support multiple offices, multiple data centers, and make sure that you have consistency across both of them. So if there's a disconnect between the data center, someone changes rules or a virus is found, when we get reconnected, we want to go and resynchronize all of those changes and policies. Now, I'll give a good example. One of the customers that we've worked with in the past is a large cruise line. And if you kind of think about what a cruise line is, these big boats, each of them have their own data center in. Because they're docked for a day, they go out to sea for a week. And when they're out to sea, they have to be able to function autonomously. So the way that these cruise ships work, they'll have synchronization happening. Once the cruise ship comes back, it resynchronizes changes from headquarters. It makes sure that all of the policies that have changed, all settings have been applied. The boat goes out, it's disconnected for a week, comes back, it resynchronizes. So make sure that you can have these branch office supports in all different types of scenarios. Because the traditional data center can now be mobile. You know, most carriers in the US Army, most ships, most tanks, they have private data centers now. So again, as they connect, reconnect, we want to make sure that we can support that. So use the term branch office loosely. Security must scale. It should be software-based. That's one of the limitations of using things like traditional network appliances. They don't scale. When you have a software-based solution that can run inside a VM, it can scale and replicate as many times as you need. It has to be automatic, using PowerShell. And you also have to make sure there's not a single point of failure. Let's say you have a single instance of the security system. It's running inside a VM, and it crashes. You don't have security anymore. You're not going to be able to report when things get viruses on them. You're not going to be able to send alerts. So make sure that security system is highly available. And make sure that it's easy for end users to use as well, if they need to. So best practices around high availability. Now, most security systems basically contain 3 parts. They contain the management server or service. They contain a database that keeps track of logs, things like that. And then they have a console, some way that you can go and connect to it and go and interact with it. You then have your hosts, your clusters, your virtual machines that you're protecting. So best practice around high availability, make sure that the security system can have redundancy, or it could run in a cluster. Even better, put it inside a highly available virtual machine. This way, if the host crashes or the host needs maintenance, you can just live migrate it or vMotion it over to a different host. Keep it up and running. Keep it redundant, so if one of those instances goes down, you need to patch it, there's a secondary instance available. Use high availability on your databases. Take advantage of things like SQL clustering. Replication, make sure that that data is always available as well. And with your branch offices, have synchronization. So the next best practices for service providers are how we protect ourselves against somebody that's in our data center using one of our VMs trying to attack us. Now, there's really 3 different types of paths that these attackers can use. First is you could get an inbound attack, meaning I'm a hoster, somebody from the outside world is attacking me. The second type of attack is I'm a hoster, somebody using one of my VMs is attacking somebody else. I have a bad guy in my data center. But the third and the hardest one for service providers to work around is when they have somebody in their data center and they're attacking the data center. That's one of the biggest threats service providers have, because service providers, they contain sensitive information. They have credit card numbers. They have other people's data. So we've heard of hackers that will actually go and figure out where a company is at hosting their virtual machines. They'll go and buy a virtual machine, get access to that infrastructure, and go and steal the information that way. So you've got to make sure that you're protecting them against inbound threats as well. So all of this traffic is constantly going in and out, from the outside world, the inside world to your storage. So here's a great example of where intrusion detection can come into play. Now again, intrusion detection, that's looking for those unusual traffic patterns. If you have a bad guy that's logged into your data center and is trying to attack your infrastructure, you're going to see unusual traffic patterns. You're going to see this person trying to access all of your storage drives, and they shouldn't be. You're going to see them try to access other memory, virtual machines. They're going to be tracing through the network, trying to understand the different routes. This is where intrusion detection is critical when you've already let somebody in your data center, making sure that you can identify it and you can lock them out as soon as possible. Another best practice, and most security solutions have this today, are custom heuristics for your data center. So again, we have all of this network traffic that's constantly going in and out of our VMs. We log it. And what this basically means is we just keep track of where the source was, where the destination was, what the time was. And what you're going to see these security solutions do is build up traffic patterns for what is normal behavior in your data center. So on a particular day, a particular hour, what does your usual traffic look like? This way, if we notice deviations, we can immediately alert you and say something unusual is happening. There's a protocol being used that we weren't suspecting. Or there's a new endpoint that's suddenly getting lots of people going to visit it. So make sure you get a solution that has custom heuristics as well, because this is building best practices for your own data center, your own network traffic. And based on what your main business is, it might vary. So traditional intrusion detection systems like Cisco Snort, they're going to catch global attacks, but they might not understand your own data center's traffic. You might have lots of developers in your data center. Developers do very odd things between 2 virtual machines where they're pushing information back and forth, flooding it. Some intrusion detection systems may flag that as a problem. So you want to make sure that you have this customization available as well. So you could say this type of traffic's safe, this isn't, and if we notice something unusual, we can go and alert our admin. I also encourage you to find solutions that are extensible. Now, most security solutions, when they do the logging, they're going to write in a syslog format. It's basically a type of event log that contains the information, the source, the destination, the timestamp, things like that. Make sure that you have a security solution that is using a third party, a common and industry standard for its logging, not a custom log. Once you use an industry standard, you have the ability to hook it into other third-party analytics systems, things like Splunk, Microsoft OMS, or Microsoft Operational Insights. If you can get that standard logging, you can go and push this data to other types of analytics systems, getting better insight, better information. If you're using SQL for your database, you could use things like SQL Server reporting services, generate information and understand how the data is being used. This way, whenever we get a problem, we'll alert on it. Now, another best practice is really around compliance, and this is big for the service providers. We touched on this a little already, but again, virtualization and cloud is different. It's a different world now. Regulators are now putting policies in specifically for cloud and virtualized environments. So traditional policies that you see from the government are now actually having mandates that if you're doing virtualization, you need to go and use different types of security, other best practices. Your customers are going to expect that you're protected, expect that you are compliant with the latest things for virtualization. And the scariest thing is hackers are way ahead of the game. They know how to go and exploit all of these different things. So really want to make sure that you're protecting everything focused on virtualization. Now the benefits, of course, here is you can improve security for yourself and your customers by following these best practices. And there's also an opportunity to make money on this as well. We'll talk about that in a moment too. Just keep in mind though, a single security breach, it really can ruin your reputation. And if you're a service provider, that in some cases can ruin your business. So I really don't want to understate the importance of security for service providers. So what's the best practice here for our service providers? Well, we can offer security as a service. Now, in the demo that I gave, we've been doing this through Azure Pack. There's other different types of self-service portals. VMware has several, and you can go do security as a service through that, SECaaS. So what does that basically mean? Well, what that's doing is it's enabling our end users to have an easy way to go and manage their security settings. You saw the administrator's experience in the last demo. I'm going to show you what the tenant, the end user, can see in the next demo here. But we want to make it easy for our end users. We want to give them templates so they don't have to think about what rules they have. We want to give them the ability to turn different security settings on and off easily. So if, for example, they're doing some development tests that's going to go flood the network, they've turned intrusion detection off for that test. So it's not going to send alerts, it's not going to log them out. So make security easy for your end users as well. Make it centralized for them too. Now, making security, I'll talk about the premium offering in a second, but what we're actually seeing with a lot of our customers is security has become so important for them now that security as a service is the default offering. They have to explicitly opt out because the best practice for you as a service provider is wanting all of your customers to sign up for it so that they are protected. Want to make sure it's easy for them to use it. And the more you do, the more you'll stand out from your competition as well. If you get better security, better compliance, you're going to be better able to perform in the market. You're going to be able to attract new customers. And if you start to add this service, you can start to generate new revenue from existing customers. But don't just think about these security best practices for your end users. Again, you're going to do that for all of your infrastructure VMs as well. So by using some of these security best practices, you're going to get better security for yourself, for your customers. You're going to meet more compliance laws and regulations, which make you more competitive, and you can go and monetize from it as well. So let's go ahead and take a look at our next demo here, what the end user experience looks like. So here's our administrator experience, and I'm going to go switch over to my end user experience. Now, in this case, think of me as a customer using Microsoft Azure, right? Everything that I do is controlled by the policies that my administrator set up for me. And you can see that I have much fewer things that I can do here. I can deploy some virtual machines, I can create virtual networks, and I can go and configure some of my own security settings. So if I want to go and protect a new virtual machine here, we can simply say new virtual machine and select it from a list. Now that this VM's protected, that's all I had to do. So through that simple step, I've gone and turned on network scanning, intrusion detection, antivirus, firewall, and applied all those default policies. So I'm not hoping that my end user logs in and configures his firewall correctly and goes and installs Cisco Snort for intrusion detection and goes and scans his network. With that one button, we've enabled them to do it themselves. And if they want to go and turn things on and off, we can simply say, turn traffic scanner on, turn it off. And again, we want to just make things easy for our end users, our customers here. Now let's go ahead and take a look at some of the information that we should be able to centrally see. Because again, centralized management is not just good for the administrators, it's good for the tenants as well. So looking at different types of information here, I can see all the different types of traffic that's been coming into my VM. Inbound, outbound, I can filter it. I can take a look at intrusion detection, and I can actually see that I've been flagged by Cisco Snort for a bunch of different alerts that I probably would have had no idea about by myself. If we take a look at our traffic scanning, we'll see that there's different viruses here. Looks like we've actually got the EICAR virus here. Now, this is actually a safe virus. It's a test virus. We actually just use it for testing purposes, but it does prove the point here. We're able to pick these up immediately. And then with antivirus, I can go and automatically configure different types of scans, different types of policies. So create a new virtual machine scan. What do I want to scan? Confirm the settings. Now, one of the best practices here as well is being able to centrally go and create new rules. So if I want to go and add a new rule here, we'll call this NIC rule. We get to specify what type of traffic, whether there's a particular IP address that we should be using, which VMs we're going to go and apply it to, additional configuration settings, like do we only want to apply this during certain hours, during certain times? Are there different IDs that we want to protect against or allow? Remote MAC addresses, confirm the settings. And we've gone and created a rule. Now what's really nice about this, I can go and export, import that rule, apply it to different places. It allows me to have automated scaling for my rules as well. So very nice here to be able to centrally manage everything. Now if I want to apply a template, for example, I can select my virtual machine. I can say use a template, and it's going to give me a list of these global templates my administrator gave me as well. So I could say, you know, this is going to be a SQL virtual machine, apply the SQL template, and I'm protected. Every time I deploy a new SQL VM, it's that easy to go and apply these security templates. I don't have to log in and configure the firewall every time and run scripts every time. We can all do this single centralized location. So as we wrap it up here, we really want to go through all of these different layers of security. Want to make sure that we have our virtual firewall in place that's going to go and prevent that network packet even arriving at the virtual machine. We want to be scanning the network as the traffic's going through, active protection, alerting us as soon as the threat arrives. We want to be scanning the disk as efficiently as possible, ideally using change block tracking. We want to be scanning the network for these advanced persistent threats, these unusual things that are specifically targeting certain types of infrastructure. We want to be doing network anomaly analysis, taking the traffic patterns from your data center and comparing them to what's usual. And we want to be able to extend it to these other third-party analytics systems. So as we wrap it up here, there's one white paper that I highly recommend. We've posted it on our website. It's from an MVP, Brian Posey, and it's specifically all of these security best practices for virtualized environments, specifically designed for service providers here. Now, I am going to just quickly jump back to the start of the presentation here because I did post this online, and this will give you the link. So if you want to actually download these slides, get these best practices, go to this link. I've posted it on my SkyDrive. I've also tweeted this link as well before the session, so if you follow my Twitter feed, you'll get access to that link as well. But hopefully what you've seen here is there are a lot of things that make security around virtualization different. The traditional way of doing security, of installing agents and having these devices sitting on the network, they don't really work that well anymore. They may work, but you're going to have blind spots in your protection. So key thing here, keep in mind security for virtualization is different. Use these best practices we've talked about, and you'll get the best protection possible for all of your infrastructure. Last but not least, monetization. This is one thing that's always a popular topic with our service providers. By making this a default offering, you could go and charge your end users more. Now, I'll give a very specific example. We charge our service providers $2.50 for every virtual machine per month. they charge their customers between $5 and $10 for each virtual machine per month. So not only are these service providers getting better protection for themselves, for their tenants, they're actually making money on this. And we have 2 different service providers that estimate they're going to make over $100,000 in the next 12 months just by offering this as their default service now. So you can buy a security solution, and you can actually monetize from it. So don't think of security as an expense necessarily. Think of it as an investment if you can go and be a service provider and go and push it up through your self-service portal. With that, that's what I have here. We'll wrap it up here. Thank you all for attending. Hopefully you learned a lot. I'll be around standing outside after this session to take questions. Now let's see. We got about 4 minutes left, so I'll take a couple now. Does anybody have any questions? So I must have explained every security best practice possible really well, right? Yeah, question.
What about security between the VM and the host?
So what about security between the VM and the host? That's a great point. So you want to also make sure that you are protecting your host, right? Make sure that that doesn't get attacked. But a lot of these best practices of protecting the disks, protecting the network, protecting the CPU and the memory, those are also the best practices that you're going to be applying to the host as well. So to your point, I probably should have had a slide here that said best practices for host protection. Make sure you're using the same policies, right? You want to have consistency on the host level as well. You want to make sure that only your administrators can access it. You want to make sure that the VMs aren't consuming the host's resources either. They're not blocking the networks, they're not consuming memory, CPUs, things like that. So if you can actually take these templates and apply them not just to the VMs but to the hosts as well, you again get that consistency and all of that protection. All right, well, thank you all for attending. Thanks.